Well, so welcome you all to the next video lecture of Dr. S.J.Sarkar electrical engineering classes. So today actually I would be discussing a basic numerical related to three-phase system. So how I could solve the numerical related to three-phase system, you could have some idea from the explanation what I would be giving here. So the problem is saying that I am having a 400 volt three-phase star connected alternator. So this is the 400 volt three phase star connected alternator, and it is delivering the power to a delta connected load. So the impedance of the load are ZRY between phase R and Y, ZYB between Y and B, ZBR between B and R. Now what we need to do, we need to find out that what is the current delivered by the alternator to the load, what is the power output of this alternator, what is the kVA output of this alternator. So there are two cases where we need to find out the three: this power output of the alternator, current delivered by the alternator, and kVA of the alternator. In one case, they would have a balanced load, so we are having equal load in ZRY equal to ZYB equal to ZBR equal to 30 plus J40 ohm. So this is a balanced load, and the next one is unbalanced load. So you could see 30 plus J40 ZRY, ZYB 40 minus J30, ZBR 30 minus J40. So all the three type of load which are here in this delta connection, they are different. So it's a unbalanced condition here. So we have to find out the three readings for these two cases. So how to do? What is given? What is given that the line voltage is equal to 400 volt. So how I had found that it is line voltage? See, it is given 400 volt three phase Y connected alternator. So this 400 volt implies that it is the voltage between the two lines. And one more point I forgot to mention, that it is given that we had to neglect that there is no loss in the power transmission from the alternator to load. So we are neglecting that. So whatever power is being consumed here, the same power is being delivered by the alternator. This is the assumption what is to be made here. So VL is 400. So the line voltage is 400. So if the line voltage is known and it's a delta connection, so what we could see that for this load actually, this phase voltage will also be equal to 400 volt. But we are not saying that ER equal to 400, because ER is basically the phase voltage of the generator. I am concerned about the load now. So for the load, the phase voltage will be equal to line voltage, because the phase voltage, you could see, it would be equal to the line voltage for all the three. Between two, it would be across this, between this and this will be across this and this. So all the three are basically line voltages, that is equal to 400. So what we can say is, since we are delivering it by alternator, so the EMF output will be balanced. So what we could say there, that VRY will be equal to 400 angle 0 degree, VYB equal to 400 angle minus 120 degree, and VBR will be equal to 400 minus 240 degree volt, or that is equal to 400 angle 120 degree volt. So this is the voltage, what is the phase voltage of the load, or all the three phases I had mentioned there. Now gradually we will be moving that how we are going to find out every parameter what is given over there. But before moving to that, let us understand something. We know Ohm's law, we know the basics of AC fundamentals. Based on that, actually, we will be moving towards that. So how to proceed this sort of thing? So try to understand the ideology first. See, the voltages are given, the impedance are given. So what I could say, we could say that there will have some current due to this voltage. So there will have some current I, R, Y in this direction, some current I, Y, B in this direction, and some current I, B, R in this direction. And we would be having some line currents IR, I had made some mistake here. Just a minute. This should be B and this should be Y. So this will be the current IB and this will be the current IY. So this is how basically we had just simply assumed the thing and we had found the readings. Now let's see how we would be moving further. So what we could see here, can we write I R plus I BR is equal to IRY. The vector addition of this and this should be equal to this if I am applying KCL at this particular point. Now what we could also write, if I am applying KCL at this node Y, what we could write? We could write IY plus IRY should be equal to IYB. And now we are applying KCL at this particular point. So what we could write? IY plus IYB should be equal to IBR. So simply by applying KCL, we are writing this. Now, what about IRY? Can we write that will be equal to VRY by ZRY? Because VRY is voltage across this, impedance is ZRY, so the current will be VRY by ZRY. IYB, simply in that way it would be VYB by ZYB, and IBR will be equal to VBR by ZBR. Now we know what is VRY, what is VBR, what is VYB. We know all the things. We know the value of Z. So we could find out IRY, IYB and IBR for all the two cases from this particular relationship only. Now once we are knowing IRY, IYB, IBR, so correspondingly we could find out what will be the line current, that is IR, IY and IB by this relation. Let it be equation number 1, this is be equation number 2. So from we would be initially using the equation number 2 to find out IRY, IYB, IBR. Putting the values in equation 1, we would be finding out IR, IY and IB. That is the line current we would be finding out. Now what is it? How we are going to do? Now try to understand the things. So we would be having two cases. One is the balanced load, one is the unbalanced load. So we would be taking the first case here. The first case is saying ZRY is equal to ZYB equal to ZBR equal to 30 plus J40 ohm. So if I would be converting it into the polar form, it would be coming to be 50 angle 53.13 ohm. So this is the impedance. So we are knowing that. So if we would be simply putting this value in equation number 2, what we can find? We can find IRY will be equal to 8 angle minus 53.13 degree ampere. IYB will be equal to 8 angle minus 173.13 degree ampere, and IBR will be 8 angle 66.87 degree ampere. So if you could observe here, you could see IRY, IYB, IBR all are having equal magnitude, that is 8 ampere. And if you could carefully see that this IRY, IYB and IBR, they are actually phase apart by 120 degree. Minus 53.13 plus this one, that is 173.13, that is 120 degree. This plus this, again you could see the difference between the two will be equal to 120 degree. Or that I could say this is plus, this is minus. So simply this minus of this will be coming to be 120 degree. So all the three are actually phase apart by 120 degree. Why? Because it is a balanced load. Now once we are finding out this, now we are using equation number 1. To find out what? We have to find out IR. So what will be IR? IR will be basically IRY minus IBR. Now if you would be solving it vectorically, then the value would be coming to be equal to 13.86 angle minus 83.13 degree ampere. IY will be equal to IYB minus IRY. Again we would be solving it. It would be coming to be 13.86 angle 156.87 degree, and IB from this equation, it would be IB, IBR minus IYB. So it would be again coming to be 13.86 angle 36.87 degree ampere. So again you could see IR, IY, IB, all three are having the same magnitude and they are phase apart by 120 degree. And if you could solve it out, what you could find that this 13.86 divided by root 3, if you would be doing, you would be getting that is equal to 8, or 8 into root 3 if you would be doing, you would be getting this one. Because you know, in case of delta connection, the relationship between the line voltage, line current and phase current is that the line current is root 3 times of the phase voltage. So we would be getting that. Now, the first thing we have to find out the current delivered by the alternator. So what is the current delivered by the alternator? That is basically the line current. So the current delivered by the alternator will be equal to this 13.86 ampere will be the current delivered by the alternator. So current delivered will be 13.86 ampere. The first point what we had found, this one. Now what is the power output of the alternator? It is a balanced load. So what we know, that the power output, that is basically the active power, so it would be root 3 into VL into IL into cos phi, where phi is the phase angle. So what is VL? VL is already known, 400 volt. IL we had already found 13.86 ampere. And what about this cos phi, the angle between V and I? So if you could carefully see the angle between V and I for all the three phases, that would be equal to this 53.13. So you would be putting the values now. Root 3 into 400 into IL 13.86 into cos of 53.13 degree, it would be coming to be equal to 5.76 kilowatt. So that is the power output of the alternator. Now power output is known to us. So what will be the kVA output? kVA output would be root 3 into VL into IL. So the values are known. So putting all the thing there, you could find out that would be equal to 9.6 kVA. So you would be finding out all the three things for this balanced load. Now this is for the balanced load. Now let's see what we need to do in case of an unbalanced load. So the case 2, when we are having different value. So ZRY is equal to 30 plus J40. So we are converting it into the polar form. So that would be same as this one. This should be equal to 50 angle 53.13 degree ampere. ZYB will be equal to 40 minus J30, that is again coming 50 angle minus 36.87 degree it would be ohm, it's impedance, and ZBR will be equal to 30 minus J40 ohm, that would be coming to be 50 angle minus 53.13 ohm. So we are having ZRY, ZYB, ZBR, and we are knowing all these relationships. So from this relationship, what we could write there, we can write IRY, putting all the values there, then this IRY would be equal to 8 angle minus 53.13 degree ampere IYB will be 8 angle minus 83.13 degree ampere, and IBR will be equal to 8 angle 173.1713 degree ampere. So you could see the magnitude of the currents are same, but the phase angle are different. So why it is? Because it's a unbalanced load. So once we are finding out the phase current, we could find out the line current following the relation, equation number 1. So we can find out this IR, the same relationship I would be putting there. The IR would be coming to be 14.71 angle minus 30 degree ampere. IY, if we would be solving, it would be coming to be 4.14 angle minus 158.13 ampere, and IB, that will be equal to 12.59 angle 135 degree ampere. So we are having all this reading right now. The phase current and line current is known. So what would be the current delivered by the alternator? So for phase R, 14.71 would be the current delivered by the alternator. Phase Y, 4.14 would be the current delivered by the alternator. Phase B, 12.59. So unequal current in the three lines. So why it is? Because it's an unbalanced load. Now, what is the power consumed? So in this particular case, we would be calculating the power consumed in a different way. Basically, we are having three phases, so we will be finding out the power consumed in the individual phases. So this should be basically the power consumed in this R phase, between RY phase, power consumed in this YB phase, and power consumed between BR phase. So that would be coming to be VRY I RY cos phi RY. So cos phi RY is basically what? That is this angle, 53.13 degree, plus VYB I YB and cos of YB. So cos of YB would be this one, 36.87 degree, plus VBR IBR into cos of phi BR. So that angle would be this one, 53.13 degree. I am ignoring the minus sign because cos of minus is equal to the value, same value itself, so I am ignoring that. So if you are putting all the values together, then what would be getting, that the power consumed would be equal to 7.88 kilowatt. And what will be the kVA output? That would be the kVA consumed. So that would be basically VRY into IRY plus VYB IYB plus VBR IBR. So if we would be solving that, that would be coming to be equal to 12.58 kVA. So that is how basically we could solve any circuit related to three-phase circuit. So hopefully it would be clarifying your doubts. If you have any question, you can ask me freely. So I'm stopping here. Thank you. Have a nice day.